Welcome everybody on Zoom, welcome everybody in the lecture hall, welcome everybody watching us from the future. So today we will continue and hopefully finish the parts on syntax. And before that, I have a question for you to check that you've been following. So what is not stored on a name node? Is it a mapping from the files to the lists of block IDs, or is it the file namespace? Or are these replicas of the blocks? Or a mapping from block IDs to lists of data nodes? So every one of these is actually stored on the name node, except one of them. Right? And 100% of you is correct. Indeed, these are the replicas of the blocks. Where are they stored? On the data nodes, exactly. Perfect. So I'm switching back to where we were. So we are going to talk about XML today. Last time I introduced you to the JSON syntax. So remember that the syntax is a way of putting in a text format what is otherwise data. And JSON was the first syntax that I introduced to you. We saw that there's objects, arrays, strings, numbers, booleans, and nulls, exactly these 6 syntactic building blocks. And we saw that a document is either well-formed or not well-formed. And well-formed is the name we have for the yes-no question. Is it well-formed JSON or is it not well-formed JSON? I also showed you how JSON can be used to store data that is not in normal forms, so in tables, but that could possibly be not even in the first normal form. And now we are going to look at an alternate syntax that is called XML. That is actually more mature in terms of the ecosystem. There's a lot of tools and technologies. XML was a hype 20 years ago in research. Suddenly you had plenty of papers that were published on XML, XPath, and XQuery, and then the hype vanished a little bit. However, XML is still very popular with governments and with the enterprise environment because of this ecosystem. It's very stable, it's very mature, very reliable. And so an example of this, the screenshot here is government standards in Switzerland for how the tax returns are stored. You might know that if you file a tax return, now there's a web application, but it used to be Java software that you could download. That was XML, all the QR codes. And in the same way, the bank statements that are issued to you and that have the QR code on it, it's also XML inside. And this is an example of that's a sample from the government. You can actually see that they have a good sense of humor in the Swiss government. All right, and then I'm going to show you the syntactic building blocks of XML. So the first building block is the element. So in JSON, you had the curly braces, you had the square brackets for the arrays, and now we also have the angle brackets in XML. It's also called the tag soup because these are called tags. This here is an opening tag, right? What you have right here. It means that you're opening the element foo, and then you are closing it right there, right? So you open it and you close it. And then you can put whatever you want inside. It's fully generic, and I will show you how you can put further elements and other constructs. There is also a shortcut that is called the empty tag when there is absolutely nothing inside. Right? And that you can have as a shortcut with the slash at the end right here. It's equivalent to an opening tag immediately followed by a closing tag, right? It's the same thing. So do not confuse the closing tag that has the slash here at the beginning of the tag, and the empty tag that has a tag at the end, right? And if you are worried about the empty tag, then just don't use it. Then you can just put an opening tag and a closing tag, and that's also just fine with nothing in between. So this here is the element. That is the first syntactic building block of XML, okay? The second building block of XML is an attribute. An attribute is inside an opening tag or an empty tag. And it's a key value model, so it has a name. That's the name of the attribute. And then you have the value of the attribute that must be quoted, double quotes or single quotes, right? So key value. And you can have many attributes if you want in the same elements, but they just have to have distinct names, right? So this is the attribute attr with the value. So this is the second syntactic building block. The third syntactic building block is text. You can put text just like that without any quotes inside tags, right? And this is just normal characters, all right? So who has ever seen HTML before? Many of you, right? It is a cousin of HTML, right? They actually have the same origin. It's just that in HTML, you can actually have a lot of imperfect things. For example, you could not quote attributes, or you also have some extra escape sequences. But in XML, it's extremely strict. You really have to quote the attributes. And so this is very popular in the publishing industry because you can have scientific papers, you can have books written in that format, and you can use the tag for formatting instructions. For example, you could put some text, and then you have tags that say this is bold or this is italic, right? B is for bold, I is for italic in HTML. So this is one way to use this, right? Now in HTML for websites, we have more modern ways of formatting with styles, but back then we could use the tags in order to do that. But in XML, the tags can be absolutely anything, right? It's fully generic. I can call them whatever I want to call them. The fourth element, a syntactic building block, I should call it, the fourth one is a comment. A comment is something that is not technically data, it's just in there, and you can explain what you're doing or something about the format. Now they look very exotic because you see this exclamation mark and dash dash, and then you finish with a dash dash. This is just for historical reasons. It used to be, there was a standard called HTML a long time ago that the publishing industry was using, very complex. And at some point, there was this willingness to simplify the standard. And what they did is that they just excluded plenty of features from the standard. And then some of these things like this remained in the way that it was before. So this is the reason why it looked complex, but this is really always like this. The comment always has these characters and then ends like this. Okay, so this is the fourth syntactic building block. Then you can have at the beginning of the XML document a declaration that it is XML. And that would be, for example, the way it looks like. It's always like this, XML version 1.0. The other one is 1.1. There's not much of a big difference. And then the encoding, UTF-8. I told you about that. This is how it's encoded from text to bits. So this is so that whoever is reading that file knows how to decode it, right? Just by picking at this declaration, they will know it's UTF-8. The encoding is optional, and the version can be 1.0 or 1.1. 1.0 is still very much around these days. All right. And so now concretely, if we put that all together, this gives us well-formed documents. So here you have an example of well-formed documents where you have the just one element that is actually empty, right? So this is the empty element foo. And above it is the text declaration that you see right here. It's just telling you this is XML, but this is really not part of the data itself. So this is just one closed and empty element. All right? Then you can have just that element without text declaration. It's fine too. What is forbidden is to have two top-level elements, right? You cannot have both foo and bar. These are two top-level elements. This is not allowed. There has to be exactly one top-level element in a well-formed XML document. What you can do, however, is nest the elements. So you can have here the element foo, right? That closes here, opens here, closes here. And inside the element foo, you have the element bar. Okay, so you can nest them. Just like in JSON, you can nest objects and arrays, right? You can have an array in an object in an array in an array. And here in XML, you can have an element inside an element. Okay. What you cannot have is also text at the top level is also forbidden. The text must always be within the elements, like this. This is fine. So you have here a top level element, opening tag foo, closing tag foo. And inside that element, we have a bit of text, followed by a nested element, followed by text, right? Again, imagine in the publishing industry, you would have an entire scientific paper like that, the text, and all over the place, that could be, for example, a new line tag, right? That tells you this is, it's called HR, I think, in HTML, right? That tells you this is a new line, and so on. Okay? You are not allowed to have tags within tags. They must be between tags. Right? So you can put tags between an opening tag and a closing tag, but not inside an opening tag. So this is not allowed. Okay? This must be like this. An attribute can also not contain these tags that cannot also not appear inside an attribute, right? So it must be the only place where you can have the elements is between elements. So here I just removed this special character. Okay. The next thing you need to know is you might see sometimes this doc type thing at the beginning. It's also not really part of the data. This is just a declaration that says this is an XML document and its top level element is called document, which we already know just by looking at it, right? But this is something that you might also see. Who has ever seen doc type HTML? Right, that you've seen. And indeed, in an HTML document, the top level element is called HTML. And so you might see doc type HTML right above it between the element declaration and the documents. So to summarize everything, elements can appear just once on the top level and then between element tags, between the opening and closing element tags. Attributes can only appear inside opening element tags, right? Or empty element tags. This is just a shortcut. Text can only appear between element tags, right? An attribute value is not considered text for the purpose of XML. So the text is really between the tags. And then the comments can appear at the top level or between element tags. Okay? All right, who is with me? Right? XML is complex, right? I'm not going to teach you all of it. I'm just going to teach you the little bit of XML that you need to read data that is stored in XML when you download data sets in XML. Just like in JSON, you cannot have multiple keys in the same object. In XML, you cannot have multiple times the same attribute name in the same element. So here, they are both in that element opening tag, A. This is not allowed. You cannot have twice the same attributes. They have to have different names. This is an example of elements that has two attributes, foo and bar. This is allowed. This is not allowed, right? Just like JSON objects that cannot have twice the same key in the same object. The next thing you need to be careful about is that when you open and close the element tags, you have to make sure that you don't close it in a messy way, meaning that if you open A, and you open B, then you need to close B first, and then close A. This is because B in itself, the entire element B, opening, closing, must be entirely contained within element A. Here, it's not okay, because you're basically closing element A, but you've just opened element B and not closed it. So this is forbidden. You cannot close element B outside, right? It has to really nicely nest in a good way, all right? Then since a few things are not allowed in XML, for example, you're not allowed to have this special character smaller than, because you could confuse it with the opening of the tag. So this is not allowed. You know what we do when something is not allowed? We escape it. In JSON, you cannot have a double quote on its own within a JSON string. You have to escape it. And in JSON, we escape it with what character? What character did we use in JSON to escape characters? You remember the backslash? Backslash quote, backslash apostrophe, backslash. So this is how we escape in JSON. Well, in XML, we escape with the ampersand, and then a semicolon. And LT means lower than, okay? Lower than. And there's only 5. That's easy to learn. There are only 5 such sequences in XML. There's LT, lower than, greater than, GT, apos for apostrophe, quote for the quote here, and M for ampersand. Okay? Do you know why ampersand is called ampersand? That's a nice anecdote. So you know that the English alphabet today has only 26 letters, right? And it used to be that it had more. It had some extra symbols. For example, th was a character of its own. It still exists actually in Iceland. In Icelandic, you still have these characters, but then they got removed, and now we use th for the th sounds. And another one of these special characters was this one. That was one that actually never really quite disappeared. And that character, it actually comes from the French ET. If you look closer, it's almost like an E pasted with a T, A, which means end. And so it's used whenever you want to say something and something, you can use the ampersand. And that was at the end of the alphabet. And it was pronounced end. And so when you said the alphabet, A, B, C, blah, 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 X, Y, Z, end, that sounded weird. And so in order to teach it to the kids at school, what they did is they added before the end, they say end per se, which means end all by itself, this character. And so when you say the alphabet, X, Y, Z, end per se, end, and you say it very quickly, X, Y, Z, end per se, end, ampersand basically appeared. So it's a contraction of end per se, end, right? That was just an anecdote, so historical anecdote, so that you know it. All right. And so since we have these escape sequences in XML, when we have a quote like this, we are not allowed, just like JSON, to have a double quote within a double quote because we wouldn't know how to parse it. You remember that in CSV, we would double it, right? We could double the quote. In XML, we just replace it with the escape sequence. So from the previous page, ampersand quote semicolon, that is the escape sequence for this character. And here again, we escape it like this. Okay? The same goes if you have this character that you have within an attribute value, you just escape it in this way, and then you're safe. All right? So to give you the complete rules, whenever you have text that is within two tags, you have to escape these characters. They are not allowed, right? So you have to escape lower than and ampersand. The other ones are fine. This you can have. But lower than and ampersand, you have to escape. If you have in a double quoted attribute value, you must also escape these two characters, but also the double quotes. So this is why if you look at this double quoted attribute here, it's okay not to escape this, but you have to escape the other three. And if you are in a single quoted attribute value, which is allowed in XML, then the double quotes can be on its own, but you have to escape the apostrophe, right? The single quotes. All right? Now, just to make it clear, I don't want you to be proficient as XML or to be able to suddenly produce a lot of XML content. The one thing that I would like you to take out of this course and section is that if you look at XML, you understand it. This is what I would like, right? You see an XML file, you can parse it, and you see the tree in your head. That is my goal for you. So when you see these escape sequences, ampersand LT, you know that's a lower than sign. when you see a ampersand quote, you know that's a double quote, right? And then when you look at the tags, you see, oh, this is an opening tag, this is a closing tag, and now this is an element within an element, right? This is what I would like you to just be able to see an XML file and understand it, right? And you'll have some in the exercises for that. A few more things that I can tell you for XML names is just like in a programming language like Python, for example, you cannot start a variable with a digit, right? It has to start with a letter. The same goes in XML. It's not allowed to start the name of an element or an attribute with a digit. It has to start with a letter, or an underscore is fine too. You can obviously also not have these special characters, so lower than is not allowed in the name of an element, because that would be confusing to the parser. And anything that starts with XML is forbidden, but this is also because it's only because it's reserved. There's some use of them that is a bit special, and so you're not allowed to create your own. Okay? All right, and so these are forbidden, the first three, and the last two are fine. Then you start with a letter, and then you have digits, and the second one starts with an underscore, and then you have some letters, right? So I made a summary here of what is allowed anywhere and nowhere. So for example, any letter of the alphabet is allowed absolutely everywhere, including the underscore. The digits are allowed, but not as the first one, not as the first character. And you can also have colons, dots, and dashes, okay, in the names. This is fine. All right. Now, you remember that when I showed you JSON syntax, I showed you that it can be pre-printed, right? You can nicely put the values in an arrays on separate lines. You can put the key values of an object on separate lines. You can also nicely indent the keys that are in the same object. This is called pre-printing. And in XML, you can also pre-print XML. So for example, here there's a bunch of nested elements. So this pre-printing makes it easier to parse, right, for a human. Because here you see that you have items that opens here and closes here, the element items, opens, closes. And now, because of the indentation, you see there is a first a child element here, item, a second one right here, and a third one right here. Who sees that the indentation makes it easier for a human? Right, very good. And here inside this one, you again have two nested elements. Inside this one, two nested elements. Inside this one, two nested elements. What is very nice is that there are editors for XML and JSON. Oxygen is the one that we have at ETH that is free for use for everybody. And you can basically download a data set from the internet, some XML or JSON data set that you just downloaded, for example, from the Federal Office of Statistics and so on. And you can open it in an editor like that, and you can click on a button, and it will automatically indent it nicely for you as a human so that you can read it, right? So it's effortless, and they just do it for you, okay? Now, we can actually have fun. Can you catch a few issues based on what I told you? This text file is not well-formed XML. It has a few issues. Can you spot them? Yes? I didn't, maybe the microphone would... Yeah, you have to press the button. Yeah.
The closing tag of movie has a capital letter?
Yes, exactly. Absolutely. So you see here, we have movies that has an uppercase M and here a lowercase m. So this one is not well formed, right? The case is important. Do you spot anything else? Yes, over there? Yeah, right one.
The comment on like famous movie, the double dash before the 80s is not valid. Further down, like 4 lines down.
I cannot understand.
The comment, like the one of the lowest lines, famous movie of the 80s, the double dash before 80.
Double dash, let me see.
Further down, yeah, there.
Here?
Even further down. You have on the last line before the closing tags, you have a comment.
This one here?
Yes.
Oh, yes, absolutely. Indeed. That is normally at the end of a comment, and so you cannot have this double dash in the middle. Absolutely. Only at the end of the comment. Yeah? Anything else? Yes, over there?
The DE in comment lang should be a string.
The DE, it's not quoted, right?
Yeah.
Where is it? DE.
Third last line.
Third last one. Here. Yeah, absolutely. We have here an unquoted attribute value. This is not allowed. In HTML, it would be allowed. The browser is not going to complain, but in XML, people are very strict, right? So you really have to have the quoted, single or double, but yeah, indeed. Another one? Yes?
You have twice the attribute text.
Yes, absolutely. Here, text and
further up.
Is it the third one? Here, exactly. Text. You have twice the same attribute. This is not allowed. Right? You're doing well. This is great. I have good news for you, because when you have documents like that, that might have that you're trying maybe to create, an editor is also going to point you to the mistakes. Right? So this is all that there was here. The copy, of course, is not one of it's the copyright symbol in HTML, but in XML it doesn't exist. It's only the 5 that I told you that exist: LT, GT, apos, quotes, and amp. And so that is not allowed in XML. And so if you want this editor, I encourage you to go to the IT shop, itshop.ethd.ch. You can go to it and get a student's license. It's free. ETH paid for it. So take the latest version of the Oxygen XML editor. It has everything in there. It has a JSON editor, an XML editor. It has JSON schema, XML schema, which we'll study for validating the data. It has XPath, XQuery, so plenty of useful features. It reads also the JSON lines files that are typical in data sets when you download JSON data from the internet. So really, really go there to the IT shop, download it, it's free. And that can also be useful later for the, your semester projects, master's thesis, in case you deal with data like that. And also for the exercises, of course, that we'll have. Okay, and that would be when it fixes, it helps you, it will tell you the mistakes. And after you have fixed it, what's really nice with these editors is that they put colors everywhere. And the colors also make it much easier to understand what's going on. It will also put colors on JSON. Who sees that it's much easier to read as a human like this, where it's indented, there's colors, the attributes in orange, red, the elements in blue, the comments in green, you know, so much easier to see what's going on. Okay. Just a remark to make it clear that you don't need to worry about. It was fixed to make the copyright symbol, but this is absolutely outside of the scope of the lecture. Don't worry about that one. Okay. So now what's going to happen is that in a couple of weeks, we are going to be looking at the structure of JSON and XML documents, and we are going to validate them, meaning that we want them to have a specific structure. And the validation, it's called the schema, what we will use. You can have a lot of different schemas, just like you can have Python libraries, right? You can have pandas, numpy, and so on. And so for the format of the data, it's the same. You can download schemas from the internet. In XML, there are formats for music sheets. There are formats for mathematical formulas. There are formats for pictures. Who heard of SVG? Right? That's a format used in XML. It's in HTML on websites. and that is also a specific kind of XML. So just like you have NumPy, Pandas, and so on, you have all of these schemas that allow you to define XML for music, for science, for math, and so on, and so on, and so on. For taxes, the government standards, so ETH.ch, have their own too, and so on. So whenever you have a framework like this that people can contribute to, you don't want it to become a mess. Imagine if people would design Python libraries without giving them names. People just define methods, functions. Then imagine if people on the planet reuse the function names. That's going to be a big mess, right? If everybody does that. And so this is why we have the Python modules, and we do pip install with the name of the package in order to download the libraries. And when you use that library in Python, you import it, and then you use the prefix, right? Let me show you the Python. Right. In Python, you see import pandas as PD, and then you do pd.array or whatever, np.array when you use it. Who has ever done that? When you use NumPy, Pandas, and so on, exactly. And so it's exactly the same for schemas. We basically have what is called the namespace, that is the equivalent of the name of a Python library. A namespace looks very scary. It actually looks like an address that you would put in your browser, except that it will not work. This is not meant to be put in a browser. It just looks like it, but this is it. So you have here the XHTML namespace, which is the namespace for the HTML pages when you use XML specifically for a web page, right? It's called XHTML. We have here a namespace for MathML that allows you to build equations, mathematical equations in the XML format. So this is by W3, so that's the same institution that standardizes HTML. So this is the namespace. We have here a namespace for music. It's musicml.org. They also have a standard for that. Do we have musicians here? No musicians? Okay. And government standards and so on. So we have plenty of these namespaces. And the way you use them, just like in Python, you would say import pandas as PD. What you do here is that you use the special XMLNS attributes, then a colon, and then M. You need to imagine that this here is the namespace that would be pandas. That would be the name of the library you want. That's the namespace right here. And the M here, that is used throughout to refer to the elements in that namespace, would be when you say as PD. And you agree that when you import a library in Python, you can give it whatever name you want here, right? You could have written anything you want here, and you just need to use it in your code. It's the same thing here. We give it the name M for our documents, but it doesn't matter what name we give it, right? We could have called it something else. So this is irrelevant, okay? Now, what you can do in Python, you can also do from pandas import everything, and then you don't need to prefix them, right? If you say import pandas as PD, then you need to say pd dot blah, blah, blah when you use it. But if you say import from pandas import everything, you do not need to prefix them. Who is familiar with that in Python? You've already used Python, many of you, right? And here it's the same. We can also say, do not give it any name or something, just XMLNS, and then it's just the default. It means that all of my elements here, they are going to come from the MathML namespace. And you need to keep in mind that just like in Python, you can also define your own functions without importing any library. You can give them whatever names you want. You can also build an XML document without any namespace, just like this. That's also fine. But then there's no namespace, right? So in that case, this is all in the MathML namespace, all of this. In that case, there is no namespace at all. Who is with me? Right? Okay. Now, I insist, I've already said, in pandas, you could say import pandas as P, import pandas as PD, import pandas as PNDS, from pandas import star. Do you agree that whichever way you use, it's still going to be pandas, right? It's the same thing here. It doesn't matter if you import mathml, if you use the namespace mathml, can be foo, can be m, can be ma, can be math, or can even be nothing, just the default namespace. It's all the same. Okay? And so here's an example of an HTML page with a math formula on it. Here, you see what it looks like. You can literally put that in a text editor, open it in your browser, and it will display this. You see this very nice formula here is in fact in XML. And so you can see here that just like in Pandas, I would import both, in Python, I would import Pandas and NumPy. Here, I just import HTML and MathML. More exactly, I declare my namespaces for HTML and MathML. I give them the names HTML and math, but I can call them whatever I want. And then I put in blue here all of the elements that are in my HTML namespace, here and at the end. And in the middle of my page, the elements that are in the math namespace that are all prefixed with math. Okay, who is with me? Yes? Awesome. So now, what is very important to understand, and that's what we'll cover in 2 weeks, is that when you do that, and you use the schemas, this puts constraints on the structure, meaning that these formulas here, math, you see square root and so on, there are constraints on how you can do it, right? You cannot do whatever you want in the way you write your elements. This is specified by the schemas that we'll see that are associated with the namespaces, okay? And so there are only 4 ways that you should be using namespaces. The way number 1 is none at all. This is an XML document that doesn't have any namespaces at all. Way number 2 is one default namespace. That's like the from pandas import everything. Then you don't have any prefixes. Way number 3 is you prefix it. That would be like the import pandas as PD, right? So you take the namespace and give it the prefix M for your document, or A here, it's not M, it's A. Or several prefix namespaces, but then that's the same in Python when you import several libraries in your program, right? So here I use 4 namespaces, A, B, C, D, and then I use B, C, D, A, right, and so on. And obviously, I mean, I didn't say it, but in the same way that in Python, you cannot use a prefix that has not been declared with a library, you can also not do that here, right? You cannot use prefixes that you have not tied to any namespace, right? Very good. So in particular, a big no, do not ever do that. You could technically put your import in the middle of nowhere. Do not ever do something like that. Nobody understands that. You're going to give headaches to everybody if you do that. It's equivalent to saying that when you have a Jupyter notebook, it's better to put your imports at the beginning of the notebook in the first cell rather than have imports all over the place. Because when you give your notebook to somebody else, they will no longer know which cells to execute first and so on, right? So it's just a matter of keeping things tidy. So I put the cat here, who is very angry at that, to remind you to not do that. Only these ways of doing that are fine. Okay. So as a wrap-up, in the same way that I did it with JSON, and after the agony that you have been through, that's the most boring lecture of the semester, XML. So if you're bored, that's totally normal. And if you're also confused because it's complex, it's totally normal. But hopefully, that now should wrap it up for you. Because the whole point of XML is that we can store denormalized data, just like JSON. So look at this now. That's the same data I had earlier. I have a table here that has plenty of records. And now I have this record that earlier I showed it to you as JSON. Now it's XML. So see how it is in XML. We have sale. That is my containing element here. Sale. That's we typically use the singular form of the table name. And then product phone. You see, product phone. Price 800. Price 800. Customer John. Customer John. Quantity 1, quantity 1. So you see how we do it. The attributes will correspond to an element's name, and the value I have in my table is going to be put as text within the elements. Who sees that? Who sees that this XML represents the record? Right? So take a good look at this. This is the way to think about it. And when you download data sets from the internet in XML, they will look like this. Right? So you really, what I want you to be is comfortable. If you look at this here, you see that this is in fact a record. Who sees that it's a record? Right? Very good. That's the goal. Now, what if you have multiple records? Well, in JSON, you remember that we used plenty of objects, right? In XML, what we do is that it's a pattern, right? That's how people do it. We have one big element because it's only one element allowed at the top level of an XML document. And typically we put it in the plural form, sales, right? That's the name of the table, sales. And inside it, we put plenty of elements with the singular form, sale. And you see that now sales might have 1 million nested elements that are all called sale. And it's totally fine to repeat these element names. It's totally common in XML. One sale element per record. And if you look inside sale, you will see it's all records, but they just have different data. Who is comfortable looking at that XML and sees that it is equivalent to the table? Right? Very good. That is my goal. That is my goal. I don't expect you to be proficient at XML. I just want you to be able to parse that as human and see that it makes sense. Now, this is not pretty printed. It would require some effort, but you can pretty print it using your favorite Oxygen editor. Click on the button, and then it puts it nicely pretty printed like that. This is the same thing that I've shown you before, but now it's nicely pretty printed. I also added the doc type sales, but it's not that important, just so that it looks nice. And then you see now the hierarchy, right? Sales, then the sale elements, and inside the sale elements, you have product, price, customer, quantity, right? Okay. Now, what about nested data? Well, in XML, you can have elements in elements in elements in elements in elements in elements in elements. So you see, the way I'm going to nest this is I still have sales, sale, product, price, orders, but orders now is going to have these children, order, 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 just like in the British Parliament, right? So you just reproduce that same pattern of the plural form and then the singular form, the singular version of the name. It's only a convention for humans, right? It's just that people tend to do that. And then you see customer Mary, quantity 1, we nest here these records inside. And this is a very, very common pattern in XML. So who sees now that we can use the XML syntax to store denormalized data, just like we did in JSON, right? This is exactly what I wanted you to see. And what is important is that it doesn't matter if it's XML or JSON. You have these very heated debates on whether XML is simpler or more complex, or JSON is simpler than XML and so on. What you need to understand is that for data, it doesn't matter. You can use XML, you can use JSON. There is one thing that XML does better than JSON in terms of coverage. It's when you have things that are basically scientific papers or where you have a lot of text that you need to tag. That is the one thing that JSON doesn't do so well. But if you have structured data that looks like denormalized tables, then both of them can handle them, and we have plenty of an ecosystem for them to do that. Okay? And I'm going to give you the break, but I just wanted to finish on that slide to tell you that there's plenty of other syntaxes. And there is one that is called YAML, which means yet another markup language. But I don't think I need to explain anything to you, because I'm pretty sure that if I give that to you without explanations, you understand the structure of the data, right? Who does? Right? Who would be able to convert that to JSON? Right? Kind of, but because I didn't explain it to you, right? But you have the intuition, right? And so there's plenty of other syntax out there. What you need to understand is it doesn't really matter which syntax you use, right? In the end, we will just, as we will see, have trees in the memory. But you see, if you look closer, you recognize here something that looks like objects, right? And here, that's more like an array in here, and so on. Okay, so that is the end of the most boring lecture of the semester. I will give you a break now, and I'll give you the full 15 minutes. So I will see you at 9:20, and then we'll look at white column stores. Thank you.